Did you guys just like spray them down?
It was only like a tiny little thing.
It's like they did. They just said there is a soft lockdown drill, and I went to go turn the drill, and then like, Kenny, you're on fire. Like, there's this little quarter-sized piece of like burning material. Never happened, but now I know. If you're going to volunteer, you can't be wearing polyester, or you have to put on a smock or an apron. Yeah. Okay, so you learned. You learned synthesis yesterday, and synthesis is what we get when you have two things and they come together. So A and B come together to form AB, or A and B come together to form C. The opposite of synthesis is breaking something into its pieces, called decomposition. So synthesis is putting together, decomposition is taking apart. And it's usually just one compound breaking into its elements. One of the simplest decomposition reactions that we encounter is what you get when someone pours hydrogen peroxide on your open wound. Hydrogen peroxide, bubbly, bubbly. So hydrogen peroxide has the formula H2O2. And it is aqueous, it's actually dissolved in water. And it's going to break down into its elements. What elements is hydrogen peroxide made of?
Hydrogen and oxygen.
Hydrogen and oxygen, like that, right?
Yeah.
We're going to write hydrogen and oxygen like that, right? No, because hydrogen and oxygen are what? They're diatomic. So the H should be represented how? H2, and the O should be represented O2. Okay, and it's going to be this is going to be a gas, and it actually doesn't break down into H2 and O2. It actually breaks down into harmless water. So it breaks down into H2O, which is going to be liquid, and O2. Okay, so that's what hydrogen peroxide breaks down into. H2O breaks down into harmless water and O2. Now, is this balanced as shown?
No.
How do you know?
Because we have 3 oxygens.
Yeah, 3 oxygens over here, but only 2 over here. So take a few seconds and balance this as I pour some hydrogen peroxide into a flask and put on my eye protection. H2O and O2. I hope my tray is still outside. Is my tray still outside? Yeah. Good. We're going to need that. Okay, so again, if I'm going to make a huge mess up here and then set it up and then afterwards clean it up, I need you guys to do the work part of it. You need to balance. You need to be an active participant in your learning here. So the whole reason for doing this is so you can balance.
Are you going to blow stuff up?
I'm not going to blow some stuff up. Nothing that you can't see on YouTube, which is, why you actually need to do it in class. So I'm going to take the time. You need to actually balance. So again, one of the handy little tricks we can use is to make anything that is an odd number an even number. So we've got an even number of hydrogens and oxygens here, an even number of oxygens here, but an odd number of oxygens here. So a good start would just be slapping down a 2 in front of the H2O. Now, I recommend you use pencil because you can always erase. You can put a 2, cross it out, put a 4, erase it, make it a 6, make it a 12, whatever. Okay? So that's a good start. Now that I've done that, how many hydrogens are on this side? 4. 2 times 2? And how many hydrogens are on this side? 2. How do I balance those?
There's 2 in front of H2O.
Slap down a 2 in front of the H2O. Boom. Now, how many oxygens here? 4. How many oxygens here?
4.
Hey, that was fun and easy. Now, hydrogen peroxide will break down on its own. So, can you see the hydrogen peroxide breaking down, releasing all the oxygen in there? No. It'll break down on its own, but if you want to speed it up, we need a catalyst of some kind. Does anybody have any blood? Yeah, 1 second. Or we can use my favorite, which is manganese 4 oxide. Manganese 4 oxide is a really good catalyst for breaking down hydrogen peroxide. Here we go.
That's so bad.
Yeah. Now, it's not boiling. It's not boiling. What's actually happening is the oxygen's just coming out of solution. The hydrogen peroxide is breaking down, and the oxygen's coming out of solution, leaving water behind. Now it's gray because the manganese 4 oxide is gray, but that's it. That's what it's doing. And in a second, it'll be done. Now, if any of you have like really concentrated hydrogen peroxide, you should bring it in and we'll do elephant toothpaste. This is only 3% hydrogen peroxide, the hydrogen peroxide you buy at Walmart. But if any of you are in that, like, if any of you have family or friends that are in like a hair salon, then they have access to like 10, 20, and even 30% hydrogen peroxide. And if you did that, it'd be like, poof, steam, smoke everywhere. It'd be great. It'd be a huge mess. But yeah, if you have any really concentrated hydrogen peroxide, we can do something really cool with that. Okay, so that's the decomposition of H2O2. Pretty simple. There is one reaction that I like to do, but I haven't set it up today because I just don't have the time. And that is the explosive decomposition of a chemical called nitrogen triiodide. It's Ni3, and it's a solid that is so ridiculously unstable that just looking at it funny makes it explode. Usually what we do is we make it in the fume hood, and then we close the fume hood, and I put a sign that says, "Do not bump." And invariably, someone bumps the fume hood before class, and it goes off. But if nitrogen triiodide is going to break down into its elements, what elements will it break down? Yeah, it'll break down to N2 and I2. And this is one of those times, nitrogen's going to be a gas, iodine's going to be a solid in the form of smoke. This is one of those times where we got a 2 and a 3. Remember how we balance a 2 and a 3? Make it 6. Okay, so go ahead and balance those guys as I cue up the video.
In this experiment, we are looking at the explosive decomposition of a compound of nitrogen triiodide.
Pause. There's gotta be a way to try this out. Yeah.
Where did the other nitrogen come from?
Oops, sorry. This one?
Yeah.
Nitrogen is diatomic, so it needs to be N2.
Okay.
Just like iodine is also diatomic, it needs to be I. Most of you already balanced it, right? Back row, you've been done? So, once again, if you're trying to balance a 2 and a 3, a good way to go about that is make them 6. So how do I make this iodine 6?
2 and I.
Put a 2 in front?
Yeah.
All right. How do I make this iodine 6? Put a 3 in front? All right, so we got 2 times 3 is 6 iodines. 3 times 2 is 6 iodines. 2 nitrogens. Hey, 2 nitrogens. That was easy. So let's watch the video.
This brown compound is so sensitive when dry that just touching it with a feather causes an explosive decomposition. It
That
forms
purple stuff is
nitrogen
the
and
iodine.
iodine. Like this mousetrap, which releases potential energy from the spring, the nitrogen triiodide releases chemical energy. When it decomposes into its elements, nitrogen and iodine.
Last year, I did a presentation for LVFR, Las Vegas Fire and Rescue, and I set this up, and I didn't think it was ready to go. It was, and I didn't have any hearing protection in, and I did it in the fume hood, and I was like, my head was right at the edge of the fume hood, and my ears rang for like a week. Because it sounds like a gunshot going off. It's a rapid explosion. It's actually an explosion, like a high velocity explosion. So it sounds extremely loud. Okay, so synthesis and decomposition, level 1. Are you comfortable with level 1? No?
Yes.
Yes, okay. So level 2 is the fun one. We're going to be spending most of our time today. Level 2 would be combustion of fuels. A combustion reaction is one where a fuel, represented by A, reacts with oxygen to produce carbon dioxide and water. Sometimes they actually call it a hydrocarbon combustion. Either way, it's some fuel reacting with oxygen to produce carbon dioxide and water. The first fuel we're going to use is probably the simplest hydrocarbon that exists. Actually, it is the simplest hydrocarbon that exists, and it is methane. Does anyone know what the formula for methane is?
Nope.
Oh no. There goes my lecture. We'll ask Alexa. Alexa, what is the formula for methane?
Methane's chemical symbol is CH4.
CH4. Thank you, Alexa. So CH4 reacts with oxygen to produce CO2 plus H2O. And these are all going to happen in the gas phase. The methane is going to be in the gas phase, the oxygen is going to be in the gas phase, the carbon dioxide is going to be in the gas phase, and the water is also going to be in the gas phase because it's going to come out hot. Okay. So this is a time where we have an even number of oxygens on this side and an odd number over here. So we should use our technique. And what's our technique to get rid of odd numbers? Put a 2 in front of them. So go ahead and put a 2 there, and now you can start balancing that. Oh, I hope this works. It worked great during second and third period, but then last period, one of the AP students knocked over the soap. So hopefully this will work. Silly AP students trying to get a college equivalent course taken care of in high school. We tend to run around like we tend to run around a lot in AP chemistry. There's never enough time. We're always bumping into each other, trying to figure things out. So not for fun. Are you balancing this? When you think you might have balanced it, take a look at your neighbor's work and see if your work compares. See how your work compares to theirs. All right. So again. Handy technique, not a rule, but a handy technique. Make our odd numbers even numbers. So how many hydrogens do we have over here? 4. 2 times 2 is usually 4. 4? Okay. How many hydrogens over here? 4. How many carbons here? 1. How many carbons here? Looking good so far. How many oxygens over here?
2.
4.
1 times 2 is 2. 2 times 1 is 2. 2 plus 2 is 4. How many oxygens on this side? 2. So if we balance it, make it 4? Yeah. How are we going to do that? Put a 2 right there. Is it balanced now?
Yeah.
1 carbon, 1 carbon, 4 hydrogens, 4 hydrogens, 4 oxygens, 4 oxygens, and it's balanced. I need a volunteer who's not afraid of fire. Cool. And you're wearing cotton. Awesome. Okay. Okay, this is your implement. Put some glasses on. Let's win $10,000, everybody.
Yeah.
We're gonna win $10,000. Absolutely. You can always record stuff. I'm not one of those teachers who are like, don't record me. I might say something offensive and lose my job. I'd be like, yeah, okay. Free up. I'll just have spare time doing another job. Okay. So, Aaron, go over. Now, this is the first time I've given this to a student. Actually, the second time because, you know. So, this is how it works. You pull down, and then you push in, you hold it. And this is your implement. It will lock if you don't pull it down. So pull it down. Do that. Okay. So your goal here is this. Glasses on. Good. I'm going to make some bubbles. Your goal, over here, get the flame ready to go. Your goal is to light those bubbles after I release them, but before they get to the ceiling. So click. Oh, yeah, okay. So just go ahead, you can just go ahead and hold it down. So someone earlier today called this Fruit Ninja with fire. Oh, okay. That's my fault. That's my fault. I gotta remember how to make bubbles here. All right. Oh! We're so close. Come on, buyers, you can do it. You can make a bubble. There's a bubble. Oh, come on. We can do this. The bubble will happen. There we go. Hey! Get it ready to go again. Oh, back up a little bit. You ready? Oh. I'm going to go ahead and blame the soap. Because there's not a lot of it, and it's not. There we go. Hey! Nice shot. Oh, okay, here's another one. Fruit Ninja with fire. Hey! 2 in a row. All right. Now we're going for a really big one here. Let's see how big I can make this thing before it breaks in my hand. Oh! Okay, more soap. Hey! Okay, one more. No. Yeah, I can't end on a failure.
You should do 2 of the same.
Oh. Hey, all right. Want to go hit that one? Yeah, just go ahead and nail it. Boom, there we are.
What?
What happens if she lights it when the gas is still on?
What happens if you light it when the gas is still on? So, fun fact, you would think that if you lit an open torch an open valve while the gas is still on, it would basically like blow the school up. What's the problem with that logic?
That it doesn't?
There's no oxygen. So I have actually done, I can't do it today, but if you ask me later on, I will do it. If I open this valve and then just light the valve, the gas coming out, it'll send out a jet about this long, and it'll go this big ugly flame, but it won't go back into the pipe because there's no oxygen. Take away the oxygen, no fire. All right, so that's fun. So that's methane. If you turn methane into an alcohol, you get dragster fuel. And it's called methanol. So methanol is CH3OH. And this is going to react with oxygen, and it's going to produce CO2 and H2O. Now, in balancing this, there's a trick. Write this down, I'll tell you the trick. Some of you might even be able to figure out the trick. While I go figure out why my 3D printer is making strange noises. Just my imagination. Got minor, yes. They're going to be going into February as I make Chemino tiles. All right, so this is methanol. This is methanol reacting with oxygen to produce carbon dioxide and water. Now, the formula for methanol is CH3OH. However, when you want to balance it, it might be a good idea to combine the hydrogens and write this as CH4O. Okay, does that make sense?
Yeah.
Oh.
Yeah.
Okay, so this is not methanol. This is methanol. This is not methanol. But it might be a good idea to combine them just to make things easy. Now, let's use our technique to reduce odd numbers to even numbers. So do you see any even numbers we should get rid of?
Even numbers here?
I'm sorry, any odd numbers we should get rid of?
The oxygens.
Yeah, let's put a 2 up here, and let's put a 2 over here, so we can get rid of those ugly odd numbers and make them even numbers. Then go ahead and balance it. And I'm going to need another volunteer that's not wearing polyester. Okay. Quincy, come on up. You're going to need to pull your hair back though, because you are going to be encountering fire. So, hair back, goggles on. So, got some glasses. Okay, so while Quincy puts her glasses on, is this something you can balance? It's not as complicated as it looks. So, how many carbons do you have over here? Two. How many carbons do you have over here? How can you fix that? Put a 2 up here? Okay, now, how many, be careful, how many hydrogens do you have over here? 8. How many should you have over here? You should have 8, but right now you only have 4. How can I make there 8 over here? Change the 2 to a 4. You can erase? You can erase. Okay. You can definitely erase. Cool. Now, let's take a look. We got 2 carbons, 2 carbons, 8 hydrogens, 8 hydrogens. How many oxygens do I have over here?
6. 8.
2 times 2 is usually 4, and 4 times 1 is usually 4. 4 plus 4 is 8, right? So I should make this number 4, right? No, because I've already got some oxygen over here. This whole side needs to be 8. I've already got 2 here, so what's this number going to be?
3.
Close.
3.
I have 2 by 2 is 4, 4 by 1 is 4, I have 4 and 4, I have 8 oxygens here, I have 2 oxygens right here. This has to be how many? 6, so the number has to be 3. Okay. Now, Quincy, have you ever looked inside the cylinders in your car?
The what?
The cylinders in your car, you know, where the explosion happens, where your car goes for it. Okay, well this is what it looks like. You see that? Okay, so go ahead and hold it like this and strike it a few times. You have to practice of striking it. So basically, what happens in your car is there's a cylinder about that big. If you have a big truck, about that big. And what happens is you put fuel in there, there's a little spark, and the spark explodes. So